The following is a video over 1-4 notes, and this is angle measure. What I want to do is to show you a geometric tool here called the protractor. Oops. Um, and what this does is this actually measures angles, okay? And so we have this thing here. It's a circle, a half circle. We can actually measure this as a full circle. And what I want to show you guys first of all is if this is my my first edge here. If we measure from here, here's 0. We go all the way around the circle. We go 360 degrees. Okay. We can also go the other way and get back here too at 360. So, but it's a very useful thing that we have here. We use circles and measurements to create a lot of things. Circles play a really integral part in angle measures and triangles and stuff like that. So, and that continues all the way on through, calculus and beyond. So, but the first thing I want to do is just, measure some sort of angle here. Okay, so if I select this, let me just draw an angle here real quick, and we'll kind of go from there. So if I draw my first ray here, my other ray here, rays are lines that have endpoints, and an angle measure really just shares that common endpoint, okay? And we call this point here the vertex, okay? Let's go ahead and call that. We also have, we'll probably have another point here. We'll probably call this, we'll just call this point J. We'll have a point over here. We'll call this point E, and then call the vertex point O. Okay, so we have the sides of the angle here, and then we have the vertex. Okay, so what I want to do real quick is I'm going to measure this angle here. And so let me see how far this thing opens up. That's kind of how I describe it. If I'm measuring an angle, I take my protractor and I put where these two lines, wherever all these lines intersect here, at this point here, is where I put the vertex. And then I line my very bottom line up with the 0, okay? And what I can do is then you want to just kind of count. Okay, we start at 0, 0, 10, 20, 30, 40. And if we take this up and we kind of match it up and see where it goes to, we're at 40, okay, but then we got to look ahead and we're just a little bit past it. Looks like we're about at 41. Okay, and this will actually measure that angle, and I bet it's going to be close to 41, and it's 41. Okay, so that's the measure of it. And we have a bunch of different kinds of angles. And so the one thing I want to do is say how we would name an angle like this. Okay, now we use all 3 points when we do this. We use the J, the O, and the E. And so what I would do is I would want to call this angle, and this little thing right here denotes angle. And I would say EOG, okay? And that's one way that we could name this angle. We could also name this angle JOE, okay? And so the O is the vertex, okay? And notice how the O is in the middle on each of those. This is the only 2 ways to actually name this angle, okay? No other ways. The only other way, I'm sorry, I should have said that. The only other way is if you have a number in here, and let's say that this is just number 1, okay? It's the first angle. We could also call this angle 1, okay? And we would say that angle 1 is equal to 41 degrees. Okay, we would say that angle EOJ is equal to 41 degrees. And then the angle JOE is equal to 40 degrees. Guys, this is the same angle. I can write it 3 different ways, okay? And so either it's got a number or it's got letters. I kind of like this one. I'm not going to lie. I like how that one looks. Okay, so let's just talk here real quick. An angle measure. And an angle is 2 rays. All right, 2 rays that share a common endpoint. A common, endpoint. Okay. And I also want to say here that these are measured in degrees. Okay. There is another way to measure angles, but we will talk about that later. Okay. And so I just want to draw a quick picture of, just a generic angle measure. And, what I'm going to do is just going to put a block there. I do want to denote, guys, that this is the vertex. Okay. And these two pieces here, this piece here, that ray, and then this ray as well are called the sides, okay, of an angle. Okay, I showed you how to name this above an angle. So let's take a look. We've got a couple different kinds. We have an acute angle. An acute angle is an angle that measures from 0 to 90 degrees. Okay, so any angle that has an angle measure between 0 and 90 degrees, we'd call acute. Okay, and so if I was to draw a generic angle here, I would say that this angle measure, um, let's just call it 30 degrees, okay? And so it's called this, angle 1. So we'd say angle 1 is equal to 30 degrees, and we would call that an acute angle, okay? Because it has a measure of 30 degrees. Another angle that we have is a right angle, and these are really, really, really important angles. There's a lot of math that goes on if you have a right angle, and this just basically it's a 90-degree angle, okay. So it's 90 degrees, okay, and a right angle is just a 90-degree angle. There's only one kind of right angle, and that's a 90-degree angle. There are an extraordinary amount of acute angles in between 0 and 90, but a right angle is only 90 degrees, okay. Um, and this should say, I'm sorry, guys, this should say obtuse. So go ahead and cross this out and rewrite this as obtuse. Okay? And so an obtuse angle is any angle that's between the measure of 90 degrees and 180 degrees. Okay? And so let me just draw a little quick sketch of that. And that would be, one side there and then another side that goes over here. And let's just say that this is, I don't know, 130 degrees or something like that. Okay, so 130 degrees. And then we have a straight angle. Okay, and a straight angle is also another very important angle. That's an angle that measures 180 degrees. Okay, and so if I draw a straight angle, okay, these are actually two opposite rays, okay, and they share a common endpoint. Okay, and so this angle measure here, if you have a line that goes straight across, you can actually measure that angle, and that's 180 degrees. Folks, we are going to be looking for this and this a lot, okay? So let's kind of continue on and identify some angles that we have. So given a picture like this, it just wants us to, name a few things about this angle. So I want to name the vertex of this angle, and the first one we're going to look at is angle 4. And I see that my angle 4, okay, angle 4 is right here, okay, and this is the part that opens up right here. So it's this angle here. And it wants me to name the vertex. Well, the vertex is at point T. So I'm going to write T, okay? Now, the other one, it says it wants angle 1. All right, so if I come over here and I look at angle 1's right here, and it's composed of these sides. And I want to name the vertex, and the vertex here is W, okay? All right, and then it says name the sides of each angle, so angle 4. And so I'm going to call that, and if I'm going to name a ray or name the sides, this is a ray, okay? It has an endpoint and has another point on that line. So I'm going to call that ray TS, okay? So it starts at T. And so when I name that, I have to have a line over the top with one arrow. Now notice that my endpoint is the same point as T, and the arrow is on the S because it goes through the S. Okay, so that's how I'd name it. Number 4 is angle STV. All right, so STV. Name the sides of that angle. So if I were to actually name that, I would call it, this is this angle here, STV. V this way. So I would have ray TS, that's already there. Okay, so ray TS, and then ray TV. Okay, so all right. Anyways, number 5, write another name for each angle. So I've got angle 3. Okay, so angle 3. Let me erase some of the stuff so we can you guys can kind of see. Angle 3. That's this angle right here. So how else could I name this angle right here? Well, I have point W on that and point V on that and a vertex of T. So I can name it angle WTV, or I could name it VTW. Okay, that's another one. Okay, number 6, WTS. Okay, and that's this angle right here. All right, start at WTS, and when the number that's inside of there is 5. Okay, so I'm just going to name it 5. All right. So that's how we name things given a picture. Okay, so these things will be in instructions all throughout the year, guys. Okay, all year long. So please, 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 make sure you are okay with problems like this and you're okay naming things. Okay. All right, let's take a look at number 7 and number 8. Okay, it says classify each angle as right, acute, or obtuse. So I've got angle NMP. So I've got angle NMP. And so what I see here, guys, I see that little block. Okay, so I know that this is a 90-degree angle, and a 90-degree angle is a right angle. So I'm going to call this a right angle. Okay, so this angle right here, that was a right angle. All right, angle QMN. So I've got QMN. So here's what I know, guys. I see that it opens up, this angle opens up from N to Q. Okay, this is my horizontal. It opens up from that. So since it goes past the 90-degree angle, I know that it's going to be an obtuse angle. So I'm going to call that obtuse. Okay, I'm just looking at how far does it open up. Okay, all right, let's take a look at the next one. And okay, we've got an algebra problem. Yes, finally getting to some good stuff. Okay, all right, so we want to, we've got this figure. Okay, figure over here, and it says that I've got line BA. Okay, so line BA and line BC are opposite rays. Okay, it looks like it says that they're lines. Okay, and anyway, okay, I've got BD bisects EBC. Now there's that word, bisect. Okay, this is important, folks. This is going to come up all the time, all year long. Something that bisects means that you cut it in half. Okay? All right, if you cut it in half, that means that you have two congruent parts. Okay, or pieces. Two congruent parts or pieces. In this case, I'm going to have two congruent angles. This should say angle here. All right. So if you've got something like this, okay, you've got this figure here, and you know that BD bisects an angle, this angle and this angle, okay, this big angle is cut by this one, and so this angle is congruent to this angle. And if you see two angles with one of these, okay, one of these arcs on it and two angles, then you know that these two angles are congruent. So I can say this, that angle EBD is congruent to angle DBC. Okay, you can name this a couple of other ways, but I can make this statement. Okay, if BD bisects an angle, then I have two things that are equal to each other, okay, or they're congruent. Okay, and so then it asks us this. It says, if the measure of EBD has this value of 4x plus 16, and DBC has 6x plus 4, okay, find the measure of angle EBD. So here's what I'm going to do. Okay, I'm going to call this 4x plus 16, and I'm going to call this over here 6x plus 4. Okay, and these are measured in degrees. Okay, if I were to have a value for x, and it'll work for both of them, I'll get the same measure of degrees. Okay, so here's what I've got. Because they are congruent, because they have the same measure, I can set these two things equal to each other, and I can say 4x plus 16 is equal to 6x plus 4. Okay, and I could subtract 4x from both sides. All right, and so I get 16 is equal to 6x plus 4. If I subtract 4 from both sides, All right, then I get 12 is equal to 6x. Ooh, look at that. Divide by 6, divide by 6. Folks, x is equal to 2. Okay? So because of that, now I can find the measure of EBD. So if I write that, I'm going to say angle EBD is equal to, okay, it says 4x plus 6, but I found x, folks. There it is. Look, okay? And I'm going to say 4 times, instead of writing x, I'm going to write 2, because that's what x is equal to. So 4 times 2 plus 16, folks, then I get 8 plus 16. What does that give me? 24? 24 degrees, okay? And it probably, it seems reasonable. These pictures aren't really to scale. But guys, I hope you enjoyed this video. This is good times, okay? It's good stuff. I really hope that you guys are taking notes on this. Please let me know if you have any questions. And I know it was a long video, but glad you guys stuck it out. So talk to you soon.